Another prototypical application question deals with reducing a price, increasing the number of sales. So if you just try to think about this, if you decrease the price, you're going to increase the number of sales, but you're not going to be making as much from each sale. So there's going to be a sweet spot here. Okay, so this is kind of how you're selling things initially, and then as you decrease the price, so this would be the number of times you decrease the price by some set amount. So as the number decreases, your money's going to go up. You're going to start making more revenue. But if you keep decreasing the price, although you're making more sales, you're making so little on each one that your revenue actually decreases until you get to this point here. And we'll talk about what these points mean a little bit later. So that's kind of the situation that we're going to see in this question, where Sherry sells photos of athletes to just athletes. We don't care about this stuff, or their fans. Her regular price is $10 per photograph, and she usually sells, so, just try to eliminate non-important words. So she sells 30 photographs. That's the first fact there. So at this point, I would try to summarize this. So I'd say $10 per leads to $30. Okay, or rather, leads to 30 sales. That's right. Okay, so now she notices that if she decreases the price by 0.5 or 50 cents, then she can sell 2 more. What A's asking us for is the equation of this parabola that defines how her revenue works. So how the decreases affect the money that she brings in. So what I've done is I just kind of separated this. So looking at A, I just wrote down the information from the question. And now I'm going to try to build, when they say algebraic model, they just mean an equation that represents her revenue. Now revenue is equal to the price times the sales. So if your price is $2 and you sell 50 of them, well, then your revenue is $100. Or if your price is $3 and you sell 22 of them, then you're going to make $66. Okay, so that's how revenue works. Now in this specific situation, we don't know what price she's going to set. We know that it's $10 and she's going to take away some money and try to maximize her revenue. So what we don't know is how many times she's going to reduce the price. So that's going to be our let statement. So let's let n represent the number of decreases of 50 cents. So if she reduces the price to a dollar less, then n must have been 2, because it would be 2 50-cent decreases. So her price is equal to 10 minus 50 cents, however many times we're going to decrease the price. And the number of sales she'll get is 30 plus 2 for every time she decreases the price. That's what the question says. And so all we have to do now is simplify this. I mean, you could leave it in this form. This isn't really that bad, but it's better to write it out in standard form, because we know that that allows us to do a lot of the solving that we might need to do later. So 10 times 30 is 300. 10 times 2 is 20, so 20n. This will be minus 15n. This will be minus n squared. And you do all the expanding. So this will leave you with n squared, and then get plus 5n. So, sorry, minus n squared plus 5n plus 300. And that's the equation that you're looking for in part A. Now in part B, and I wrote this out with x's, we can use our n that we used just to stay consistent. Well, that's not consistent at all. there you go, 5n plus 300, and that's what the revenue is equal to. It says, at what price will her revenue be 150? Well, all we're doing now is replacing the revenue here with 150. So we've got 150 equals minus n squared plus 5n plus 300. And we're going to subtract 150 from both sides. And I'm just going to rewrite it a little bit. So I'm just writing the equation on the, or the expression on the left, and then the other side I'm going to have equal to 0. Doesn't matter what order you do that. Okay, and now what I probably would do next is I would just rewrite this by dividing each term by -1, just so I don't have a negative up front. I find it less confusing that way. If you're fine with the other way, that's fine. And now you could try to factor this, or what you could do instead is you could use a quadratic formula, which I would certainly suggest. B squared minus 4ac all over 2a. Okay, so you just plug in the numbers, you're going to get an answer. Now be careful, it says what price. This will tell you how many decreases. So remember that the price was equal to 10 minus 0.5n. So that's the price. So you'll have to take whatever your answer is, plug it in for this n, and you'll get the price. So leave that as an exercise. So at what price will our maximum revenue occur? Okay, well that's a little bit different. So if we want the maximum, we know that our graph is going to look something like that because it opens down and it has a y-intercept of 300. So if we're looking for that, then that's the vertex. How do you get the vertex? Complete the square. I'll actually do this process. You want to factor a negative out. Just out of the first two terms. Remember, we're trying to make it look like this. It'll look like this in the end. A n minus h all squared plus k. And that's going to be the maximum where that vertex is. Okay, so half of 5 is 2.5, and 2.5 squared is going to be 6.25. Got to add it and take it away. Now this is a perfect square trinomial, minus n minus 2.5 all squared minus 6.25 plus 300. Just bring that negative back in the bracket and we'll wrap this up. So we get minus n minus 2.5 all squared plus 6.25 plus 300, which is equal to minus n minus 2.5 all squared plus 306.25. So her maximum revenue, this is the sweet spot, is 306. So you can write out a conclusion, $306.25. And that'll happen when she has 2.5 price decreases. So the new price would be equal to 10 minus 0.5 times 2.5. Okay. So it's asking what price will our maximum revenue occur. So make sure that you put this in your answer. So this is going to be 10 minus 1.25. So it would be $8.75. So therefore, I'll write out the therefore statement for you this time. So therefore, the maximum revenue of $306.25 will occur at a price of $8.75. That's all there is to that. So what did we do? We just completed the square to find the vertex. That gave us our answer. So at what price will her revenue be 0? So again, we have our equation here. I wrote it out with an x. Let's keep it consistent and write it out with our n. It's a better letter for this case. And her revenue will be 0. So this time, it's really similar to the other question where we were figuring out at 150. We're just going to plug in 0 here. So 0 equals minus n squared plus 5n plus 300. So A is equal to minus 1, B is equal to 5, and C is equal to 300. Then all you're going to do is plug this into minus b plus or minus the square root of b squared minus 4ac all over 2a. Once you plug that in, you're going to get two answers for n. One of them will be valid and the other one won't. The last question is really interesting. It asks us to look at the graph and try to pick out important points and explain what they mean. So we've already discussed this point here. This is her max revenue. And it tells us what the ideal price is. This is the ideal number of reductions of 50 cents, right? Now this is the original situation. This is with no reductions. So $300 in revenue with no reductions. So that's keeping the price at $10. This one down here, also interesting. You notice you get no revenue after 20 reductions. Well, why would that be the case? Well, remember the price was equal to $10 minus 0.5 times n. Well, if n is 20, then 0.5 n is 10, and the price is 0. So of course you get no revenue if you're not charging anything. Now, if you keep decreasing the price, now the price is negative. Okay, that would be you giving money to the person with the product. So this is nonsense. No one ever does that. Okay, now if you go negative for reductions, that's going to mean that you're adding here. Think about multiplying a negative number here by a negative number here. You're going to get a positive number. If you get a positive number, you're adding money to the price. So this is all over here is an increase in price. You notice the revenue is going down. Now this is where there are so many increases in price that no one's willing to buy your product. Okay? Assuming that rate stays the same, that you lose 2 sales every time you increase the price by 0.5, then after 15 increases, you're going to have no one buying your product anymore. Now down here, this would suggest that after you increase the price past 15, okay, so now the price would be, let's say if we go over here to 20, then be $10 more. So now you'd have $20 as the price. Now this would imply you have negative revenue. So now you're losing money. And again, this is just nonsense over here. Because you're not making any sales, right? And so you have no revenue past there as well. So hopefully that helps you out with some of these problems. This is a prototypical question. You have to create the equation yourself, and you have to interpret what the equation is telling you. And the key math here is use the quadratic formula to solve when you're looking for the number of increases or decreases, and you're going to complete the square to look for the max.